So let's remind ourselves of what we know. If we want to take the derivative of x to the fourth, that's 4x cubed, right? So that's the in general power rule for x to the n x to the n minus 1. So that's where x is the base. What if I want to take the derivative of 4 to the x? Oh yeah, we've got that a to the x rule. A to the x ln of a, right? And if I have more than that, 4 to the g of x, I know that's 4 to the g of x, ln of 4, always ln of the number, times g prime of x, right? Okay, so those are in general rules you know. What if I have a function to the power of a function? What? Like this. There's no rule for that. So what you must do is you must do this logarithmic differentiation. Okay, so first off, you have to recognize it. I'm not going to tell you to do it. So you have to recognize it, that you have a function to a function. So your first step is to take ln of both sides. So that's step number 1. Take ln of both sides. So I did that. ln. Then you use the log property and bring that x down in the front. Be really careful. This is where mistakes happen. So go slow. Bring the x down in the front. Now we're going to take the derivative of this on both sides with respect to x. Because that's what we're trying to do, is find y prime, right? So if I take the derivative with respect to x of ln of y, I get 1 over y prime. And derivative with respect to x on the right-hand side, that's just product rule. First d second plus second d first. Okay, I think I can solve for y prime now. So I'm going to multiply both sides by y. Now, my question started in x's, y equal x's, so I need to replace y with x to the x. And then that's the answer. All right, so let's look at this one. So first off, I notice it's a function to a function. So I take the ln of both sides. Do not skip this step because this is where mistakes happen, okay? So be careful. So put the ln on both sides. This side just carries along. Now I'm going to bring this x down in the front, right? Because it's an exponent, ln of cosine of x. Okay, so now I'm going to take the derivative of both sides with respect to x. So derivative with respect to x, derivative with respect to x. So the derivative of ln of y will be 1 over y, and you know these letters are not the same, so it's y prime equals. Okay, so it's gonna be a fact that every time you take the derivative on this side, there's product rule. So you have first derivative of second. So 1 over derivative of ln of cosine is 1 over stuff times the derivative of stuff plus ln of cosine times the derivative of x, which is just 1. Okay, so now I'm ready to solve for the y prime. So I'm going to multiply both sides by y, right? Multiply both sides by y. Okay, so then, let me get different color here. Okay, so these cancel, so I get y prime equals, and then here's the y times, and then I'm going to, because it takes me time to type this in, I know that sine over cosine is tangent, so I get a negative x tangent of x plus ln of cosine of x. It's a lot less to type, right? So you have to finish it off by putting in the fact that you know y is equal to this. So your final answer will be cosine of x to the x power negative x tangent of x, tangent of x plus ln cosine of x, and that's the answer. Wow. Okay, one more. Make some room to do it. So, of course, you notice it's a function to a function, so you must use logarithmic differentiation. So your first step is to take the ln of both sides. So ln, and again, don't skip this step because this is where I see the mistakes happen, and then you get an impossible problem. So now rewrite it, ln of y equal, and then bring this down in the front. times, and then ln of secant of x. So now you're ready to take the derivative. Derivative with respect to x on both sides. So the derivative of ln of y would be 1 over y, y prime. On the left-hand side, I'm going to need product rule, so let me just move this over. Okay, so I have 1 over y, y prime equals. Okay, so let's start with this. So first, carry along the tangent, and then to take the derivative of ln of secant would be 1 over stuff times the derivative of stuff, secant x, tangent x, right? And then plus ln of secant, carry that along, and then take the derivative of tangent, which is secant squared. So I see some canceling, so let's just take care of that, right? So those cancel. I could join these two tangents together. I'm going to move it up here where I have room so you can see. Okay, so on this side I have 1 over y, y prime. That hasn't changed. Equals. So I have a tangent squared, right? And you can write that like that. And then this is inside the ln, and this is not, right? So I'm going to even put the secant squared there, and then ln of secant. Okay, so ln of secant of x. So now I want to multiply by y. So y prime equals y times all of this. So tangent squared x plus secant squared x, ln of secant of x. And so to finish it off, I want to rewrite what y is equal to in terms of x's. So I want to replace y with this thing. So my answer would be secant of x to the tangent of x times tangent squared of x plus secant squared of x ln secant of x. Wow, that's it.